Okay, so now I'm going to start your technical snap for
Yes.
PSUs on strength of materials. So Shreyas, so tell me how you define strength.
Strength, so it is the maximum stress that a material can take before failure.
Okay. And how you define stress?
Stress is an internal resisting force that a body can resist per unit area.
Okay. And how you define strain?
Uh, Strain is the percentage of elongation that is taking place in the material when we apply a external load.
Okay.
So it will be
So
a change in
in solid,
dimension.
yes,
Yes, sir.
in solid,
Hmm.
stress come first or strain?
Sir, the body is strained first, and then because of that, internal resisting force is developed. So the internal resisting force leads to stress in the body.
Okay. So how you define Poisson's ratio?
Sir, it is the ratio of lateral strain to longitudinal strain.
Ratio of lateral strain
Lateral
to,
strain to longitudinal strain.
and let us say suppose mu is 0, then what does it mean?
Uh, is zero. That means whenever we are loading the body in longitudinal direction, so it is not showing any strain or any compression in the lateral direction.
Okay. And is there any example?
So cork is one of the example, which has 0.
Cork.
Yes.
Okay. And how you define Young's modulus?
So Young's modulus is given by the slope of the sigma epsilon curve, stress strain curve, and it defines the stiffness of that body.
Okay. So can you draw a stress strain curve for MS and cast iron?
Yes, sir.
Stress strain curve for MS and cast iron.
Yes. Yes, I have drawn.
Okay. So cast iron is stronger than mild steel. Is it possible?
Stronger in the sense the ultimate point is greater than our mild steel.
Ultimate stress point is greater than. Why?
Yes. Because it is a
How it is
brittle in
possible?
nature.
How it is possible? Because brittle material is weak in tension. You are doing tensile test. Is it clear?
Right.
So is it possible?
No, sir. No. They are weakest in tension. Correct.
Okay. Okay, how you define resilience?
Resilience is the energy stored by the strain energy stored by the body up to proportional limit.
Up to proportional limit.
Yes.
And what about resilient material?
Means it is able to store maximum energy before it is going into plastic deformation zone. So that will be a resilient material.
Okay. And where it is used?
So springs are generally in springs we generally use resilient material so that we don't go into permanent deformation zone when we are straining the springs. We are applying
Okay.
the
And how we make?
springs are made. Springs are made of high tensile steel. High tensile steel. So they are made by I think they are made by quenching and then we do tempering on that to make it more resilient.
Okay. So if how you define the section modulus?
Section modulus is a ratio of moment of inertia to the distance from the neutral axis to the external fiber.
Okay.
Means
And
in
suppose you
case of
have three.
yes.
Suppose you have three cross sections.
Hmm.
Rectangular cross section, circular cross section,
Hmm.
and I section. So which one is better?
So as far as I know, I section has the least amount of just a second. I section has the highest amount of section modulus. Therefore, I beam is preferred.
I section.
Yes.
Okay. And what about if you have a square cross section of the beam, and once if it is placed, its dimension, its sides horizontal and vertical, and in another case, if the diagonals are horizontal and vertical, then what will happen on the load carrying capacity?
Means diagonally we are placing in a diamond shape.
In case one, suppose you have a square cross section whose sides are horizontal vertical, correct?
Right.
And in another case, the same you have same cross section, but its diagonals are horizontal vertical.
Okay. Sir, in this case, square is more efficient. So the section modulus for square is more than diamond.
Okay. Okay. So suppose you have, if you have hydrostatic state of stress loading,
Okay.
then which theory of failure is applicable for this kind of loading?
Sir, I think strain energy theory is used for this.
Strain energy theory.
Yes.
Why not MSST or MPST theory?
For a Sir, no shear stresses will be generated in this, on any plane in hydrostatic condition. So the MSST is ruled out.
And MD, what about MDT?
DET theory is for distortion energy theory. So distortion is only caused by shear stresses. That means when shear stress is applied, then distortions take place. No volume change or we say no elongation takes place in that case. So that theory is also ruled out, and strain energy theory is used, I think.
Okay. Okay, very good.
Yes.
Okay. How you define column?
Columns are vertical member under compression.
Vertical member under compression.
Under compression, yes.
Any other identification?
Mhm. Means for definition of column or any other term you're asking?
Yes. How any other identification of column?
Mhm.
Can any vertical member consider as column when it is subjected to compressive load?
Long columns means which will get laterally what is it? Laterally deflected. Means whatever
Okay.
column when applied a compressive load, then they will deflect
Actually,
lateral.
columns are cylinder member, correct? Whose lateral dimensions are very less as compared to its a longitudinal dimension, correct?
Correct. Yes.
And how you define slenderness ratio?
Slenderness ratio is it is the ratio of effective length of that column to the radius of gyration of that column. Minimum radius of gyration.
Okay. So for the safe design of column, slenderness ratio should be low or high.
Sir, slenderness ratio should be minimum for better column.
Slenderness ratio should be minimum.
Means the peak
Okay.
carrying capacity will increase. Yes.
Okay, let's say suppose you have a rectangular column whose width is B and depth is D, where depth is more than width. Correct?
Okay.
And parallel to depth you have x-axis and parallel to width you have y-axis.
Okay.
So now tell me about which axis this column may fail.
About depth we have x-axis, okay, and we have y-axis. So it will rotate about x-axis. I mean, it will deflect about x-axis. Since the distribution is least about that axis.
Least moment of inertia.
Yes.
Okay. One last question. Let's say suppose you have a simply supported beam, correct? And if it is subjected to a constant movement at midspan, then how you draw its a shear force and bending moment diagram?
Yes. Safety. Yes, sir. Okay. So it will be like this. So this is
Okay,
a simple.
bending moment diagram is right, and yes, shear force diagram is also right.
Yes.
Correct.
Yes.
Okay, so now I'm going to conclude your interview. Correct, say yes. So I
Yes, sir.
think your preparation is over now. Correct. With respect to strength of material, you have given almost all the correct answers.
Okay.
Correct.
Okay, sir.
So keep your preparation continuing till your interview, and rest is okay.
Okay, sir. Sir, for that distortion, sorry, hydrostatic stress condition. So answer was corrected. Strain energy theory.
Yes, strain energy theory is applicable. Why? Because MSST and MDT both are not applicable. So either you can use MPST theory or strain energy theory. So obviously, if it is ductile metal, then better to use strain energy theory. And if it is brittle metal, then will be used for MPST theory. Correct?
Yes, correct. Okay, sir. Rest is okay. I'm fine. Yes.
Okay. All the best.
Okay, sir. Thank you, sir.